In this video, we're going to take what we know now about graphing trig functions, specifically sine and cosine, and combine it with what we have seen with graphing all kinds of other functions to incorporate some different transformations. So in graphing sine and cosine already, we worked with that part, the amplitude, and this part that changes the period. And now we're going to include horizontal shifts and vertical shifts. But those are the same really that we've had in other kinds of functions before. So for example, when we had this, we'd say that here's the vertical shift, it's +1 or up 1, and then we'd set this equal to 0 and find the horizontal shift, 3 to the right. And it's going to be the exact same thing here. We're going to do the same things, and then we're going to combine them with what we know now about sine and cosine graphs. Incidentally, we could do this exact same thing with tangent graphs. We're just not going to. So let's start with this one. Y equals 2 cosine of 3 theta minus pi plus 1. And I'll try to go in the same order for all of these. I'm not going to write out the steps, but I'll say them clearly. So a good thing to make notes on. First thing we're going to do is just identify the vertical shift. It's 1 up. Second thing we're going to do is look at the amplitude. So the amplitude is 2. And what I'll do here as I start drawing a graph for this is I'm going to mark out those things first. So I'm just going to mark that our vertical shift is 1, and I'm going to put a midline there. So our midline isn't on the x-axis anymore like the previous ones we did. Now it's up by 1. From there, the graph is going to go up by 2 because that's the amplitude, and a little low on that last one, up by 2, and then down by 2. So I'm also going to put in lines in those spots, amplitude lines to represent the highest and the lowest that this graph will go. I need to move that one a little. Okay. So we've got the vertical shift and the amplitude taken care of. Next thing is let's find the horizontal shift. So remember that comes from setting that equal to 0. Horizontal shift, so 3 theta minus pi equals 0, 3 theta equals pi, and theta equals pi over 3. By the way, before we get too far along, I'm just going to label these. So up 2 is y equals 3. Down 2 is y equals -1. Okay, so we've got that. We've got our horizontal shift there. And then the one other thing we need to find is the period. So period is 2 pi over b. B is 3. So the period is 2 pi over 3. And that means our segment, each segment is a fourth of that, which would give us 2 pi over 12, which is pi over 6. Okay, so we have our vertical shift and our amplitude, and we put those in. We have our horizontal shift, our starting point, our period here, 2 pi over 3, and then our segment, pi over 6. One calculation that I'll do just in terms of scaling the graph is if we're starting at pi over 3, and then usually the directions for these will say to graph 2 complete cycles. So I need room for 2 of those. So my starting point plus 2 complete cycles. So that's pi over 3 plus 4 pi over 3. So 5 pi over 3. That's how far over this graph needs to go to give me space to do everything. So I'm going to use that to kind of label this more effectively. So I'll say that's 5 pi over 3. I'll try to label the rest accordingly. So we'll say that's 2 pi over 3, 1 pi over 3, 2, 3, that's about right. 3 pi over 3 is just pi, and then 4 pi over 3 here. Our segments are pi over 6, so our segments are going to be half of each of these. I'm not going to write out all the numbers, but I'm going to certainly label where they are. Okay, And last thing, this is cosine, and it's positive. Cosine starts at the amplitude, and since this is positive, this graph is going to start at the top. So our starting point is at pi over 3, and it's going to start at the top amplitude line. And then like every other sine and cosine graph, every segment, it's either going to go amplitude to midline or midline to amplitude. And we'll just keep going. We've marked out exactly where 2 complete cycles should end. And that's actually a useful check. So after what should be 2 complete cycles, do I end up 1, 2 exactly back where I started? Yes. So that's a good sign. And now I can draw in the graph. Remember, like I said, when you are at one of these starting points, it doesn't start down. It's actually flat at the top and curves down. That just makes the drawing process a little bit easier and more accurate. And so that would be 2 complete cycles of this function or this graph. And if we're doing domain and range, the domain, now we only showed those 2 cycles, but for the whole thing in general, the domain is all real numbers because it keeps going infinitely in both directions. The range, if we label the graph well, we can see it pretty easily. It goes from -1 to +3. That's y. So it goes from -1 to +3, and y is always in between those. So those are the basic steps. Let's do a couple more, and I've just incorporated some slight different situations on each of these just so that we can see them. So we'll try to go through this in the same order. We notice there's a negative sign there. That's going to change something. These are both fractions. We'll see what that does. But we'll start with the usual stuff. Vertical shift is down 3. Amplitude is 2. And we'll just note that that's there. That's obviously going to have some effect. So I'll start laying out a graph here. So we've got that. Now I'll move that over. We've got that in there. And so I can do a midline, and the midline will be at -3. So we'll just say that's where -3 is. And I'll label that. And then from there, it's going to go up 2 and down 2. So it'll be like there and there. So I'll put in amplitude lines for those 2 things. And I'll label them here in a second. So we've got that, we've got that. Okay, so this is up 2, so there's going to be y equals -1. And this is down 2, so this will be y equals -5. So we've got our midline and amplitude all sorted out. Let's do horizontal shift. So we'll set that equal to 0. Just like everything else, wherever this equals 0 is going to be the starting point for the graph. So we'd have pi over 3 equals theta over 3 equals -pi over 2. Multiply both sides by 3. And we get theta equals -3 pi over 2. So that just means it's a shift to the left by 3 pi over 2 units. And then last thing is we'll do the period. So find some room over here. Period equals 2 pi over b. Recall that when we have something like this, theta over 3, that's the same thing as saying 1/3 of theta. So b is 1/3. So the period is 2 pi over 1/3. If we want, we can set this up like fraction multiplication. So 2 pi flip and multiply, times 3 over 1. So the period is 6 pi. And then each segment is 1/4 of that. So 6 pi over 4 is 3 pi over 2. Okay. This graph starts to the left. I had a feeling it might, so I left a little extra room here. You can always sort of adjust where your y-axis is if it turns out you need to go way over to the left. But here we're going to start at -3 pi over 2, and conveniently our segments are also 3 pi over 2. Okay, so I'm going to do, is that going to fit? I'll go a little smaller than that. So there's negative 3 pi over 2. And then every segment is going to be that size. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so 0, that's positive 3 pi over 2. 6 pi over, so that would be 3 pi. 6 pi over 2, 9 pi over 2, 12 pi over 2, 15 pi over 2, 18 pi over 2, and 21 pi over 2. Okay, but the important thing is that each of these is one segment. Each of them is 3 pi over 2. Okay, our starting point was at negative 3 pi over 2. Our starting point's over here. It's cosine, sorry, it's sine, which means it starts in the middle no matter what. So it'll start right there on the midline. And then since this is negative sine, instead of going up first, it's going to go down first. So the first segment will be down, back to the midline, amplitude, midline, amplitude, midline, amplitude, midline. We made a point that, so you may have noticed that I messed up, right, with that last dot, but here's how I would know. We made a point that we want to graph exactly 2 cycles of this. And so my second cycle should end exactly where I started. If I'm doing complete cycles, I should end right where I started. I started in the middle, but then I noticed my last dot isn't in the middle because for whatever reason, I just derped and put it in the wrong place. But now I can catch that and say, yeah, it should end in the middle right where I started. Perfect. So now I can draw the graph itself. And close enough. That's fine. And for domain and range, domain for sine and cosine is always all real numbers. Range for this one, again, because we've labeled the graph well, we can see it's from -5 to -1. And it is important for these to be in order. If you put, these always go from smaller numbers to larger numbers. So if you put like, if you put this, that's just not the format that we use. That's going from higher to lower. We don't do that. We go from lower numbers to higher numbers. Okay, we'll do one more here with one other little twist. But we'll start out the same way we always do. Vertical shift, it's 1 up. And amplitude is 4. And I'm going to hold off on marking up or starting a graph just so I can kind of show you what's going to happen here. We'll do horizontal shift. So pi minus 2 theta equals 0. This is easy enough. Pi equals, no, yes. Okay, there we go. Pi equals 2 theta. So theta equals pi over 2. Okay. So I just added 2 theta to both sides there. Okay, so that's our horizontal shift. And then for the period, we will have period is 2 pi over b. B is 2, the number that's in front of theta. So period equals 2 pi over 2. So the period is just pi. And the segment is 1/4 of that, which is pi over 4. Okay. What's different in this one is that this is actually -2 theta. So imagine if we wrote it like this. That would be the same thing. And so this is different. We're basically not doing cosine of theta, we're doing cosine of negative theta. And that's going to really change how it acts. So as I start this graph, what I'm going to do is say, well, if we're basically graphing negative theta, then whatever it normally would do in the positive direction, now it's going to do that in the negative direction, which means that my graph, the easiest way to do it is going to be not starting somewhere and going to the right, but actually starting somewhere and going to the left. because the behavior I know is now, it's not what theta is going to do, it's what negative theta is going to do. So here's how that's going to look. Let's start with our vertical shift and amplitude. So we'll mark those in there. We've got 2, 3, 4, 5. So we've got our midline at 1, and then we go up 1, 2, 3, 4, and then down 1, 2, 3, 4. So let me put those lines in. So we've got amplitude line, midline, and other amplitude line down there. And I'll label those. If nothing else, we saw how it makes it really easy to determine the range later on. So up 4 and down 4. Okay. Our starting point is pi over 2. And so I'll put that over here. It's fine. And our segment is pi over 4. Actually, I'll give that a little bit more space here. So we'll put that way over there. There's pi over 2. So pi over 4. And then we'll mark out. So there's going to be 2 more segments. So this is 0, negative pi over 4, negative pi over 2. I didn't scale this great, but that's okay. And then we'll do another 4 segments to get one more complete cycle of the graph. So that would be negative 3 pi over 4, negative pi, negative 5 pi over 4. So this was negative 4 pi over 4, which reduces. This will be negative 6 pi over 4, which reduces to negative 3 pi over 2. Okay, so I didn't scale that great, but that's okay. And so what we're going to do, because this is negative theta, we're going to go backwards, and it'll have the same behavior that it normally does going forwards. Okay, this is cosine. It normally starts at the amplitude, it's positive, or it does start at the amplitude, it's positive, so it starts at the top. So normally we would go right and down to the midline. So instead, we're going to go left and down to the midline. And whatever we would normally do going to the right, now we're just going to do that same thing going to the left. Why is that? Well, since it's negative x, that means that whatever it would normally do going in the positive direction, now that's what it's going to do going in the negative direction, because those negatives are all going to act like positives. So in short, you're doing the same thing as usual. You're just going left instead of right. I didn't quite get that. And now we can connect the graph in the usual shape. And of course, we could draw it from here too, if we're more used to just drawing in that direction. Okay. It doesn't matter where your 2 cycles are. They can be left of the the y-axis. They can be to the right of it. They can cross it. I'm not going to ever say, oh, you need to draw 2 cycles that are to the right of the origin or whatever. Any 2 cycles are fine because it's the same thing infinitely in both directions. So it ultimately doesn't matter that much where you do it. And so we've got our 2 cycles there, and we'll do domain. Again, all real numbers. It's not just the part that you're graphing, it's the domain of this whole thing. And then the range, we can see, goes from negative 3 all the way up to 5. So that's how you graph these full transformations of sine and cosine. Again, you could do the same thing with tangent, but we're just not going to. I forget if I mentioned that already. But we've got, like all the other functions we've studied, vertical shift and horizontal shift. That's kind of sitting there. This you set equal to 0. So we've got vertical shift and horizontal shift. Then we have midline and amplitude, like we've seen with other trig functions. We have the period, like we've seen with other sine and cosine graphs that we've done already. And then a couple of special circumstances that we looked at here. One, when the graph is flipped, which just means you started in the opposite direction. By the way, if this were, let's say, negative 2 cosine, cosine always starts at the amplitude line. Positive cosine starts at the top. If this were negative cosine, then it would start at the bottom and work its way up, just if you get one of those. And then we had an example with negative theta here, which means whatever theta normally does going forwards to the right, now that's what it's going to do going backwards to the left. So just a few variations and different kinds of transformations that we can make from these sine and cosine functions.